everybody. My name is Amie Stepanovich. I am the Executive Director of the Silicon Flatiron Center for Law, Technology, and Entrepreneurship at Colorado Law School. Thank you for joining us here today. We have a really great conversation lined up. And we're going to be talking about rights in the digital world, how technology supports data protection through innovative privacy-preserving technologies. In particular, I like to think that there are two primary drivers of data protection. The first one being the law and regulation, and that being a very important, necessary prerequisite. And for those of us in the United States who are not in California, we must just look jealously at regions and countries like the European Union who have passed the GDPR on this question of the law. However, there is a second driver of data protection, and that is the technology itself. So this is where we're going to dig in a little bit today, talk about what is being done in the tech space to best protect privacy, which is something that's even recognized, the second driver is even recognized by the GDPR in Article 25 that calls for privacy by protection and by default, privacy by design and by default. So I'm going to welcome the panelists here today. We have Françoise Beaufays, a research scientist at Google, Yves-Alexandre, an associate professor at the Imperial College of London, and Calvo Medina, a data inspector and head of Area Innovation and Technology Division at the Spanish Data Protection Agency. And I'm going to start with Françoise, actually. Françoise, you work on privacy-preserving technologies at Google, and in particular on federated learning. So can you talk to us why privacy preservation and privacy enhancing technologies are important to Google and what you're looking to achieve in your work in particular?
Yes, thank you, Amy. Thanks for having me here today. I feel especially honored that this conference is hosted in Brussels, because Brussels is actually where I grew up. So I'm feeling back home today. You asked me about Google's interest in privacy-preserving technologies, and I think that much of the work that we do stems from the success of AI. A lot of products and features of those products have been moving to AI in the last about 10 years, let's say. And AI means deep learning, big neural networks, and those provide obviously, much better quality in the products, but they require a lot of data. And that, of course, puts more weight on the people and the institutions who handle this data and more responsibilities in their hands. And this is where we start looking into these privacy-preserving technologies. So the way that we think about it is really multifolded. First of all, we look at Google into original, innovative research in this domain, finding new privacy technologies, applying them to different use cases. We also look into data minimization, so doing more with less wherever we can. And where we do need accessing data, we try to keep the user data local, meaning to keep it on their device wherever it is possible, right? It's not always possible, but in some places it is. And those are the premises of federated learning with all the applications that we've been working on. In terms of how Google thinks about it and what we're trying to aim for, I would say that it really goes through the whole spectrum, right? We start with the research and we try to develop new algorithms, new methodologies to do things, but we also want to put them in production and to put them in production at scale. Because I, at least personally, believe that it's only when something is fully in production and that you see the technology working for our users that we can say that it's truly successful. So we do these efforts in production, and then of course we try to share our learnings best we can through publications, conferences, and open sourcing. So our hope is really that not only do we invent, validate technologies, but also that we share them so that academics and government and nonprofits can benefit from our work.
Thank you so much for that. I now want to turn to Yves-Alexandre. A lot of your work has been focused on showing how de-identified anonymous data sets actually aren't what they pretend to be, and they can be re-identified. I think you have shared that 99.98% of the US population can be re-identified with only 15 attributes. So are these privacy enhancing technologies that Françoise talked about, are those going to put you out of a job? And what is your research looking at?
Yes, perfect. Thanks. I think I had slides. I don't know if we can see them or should I do without? No worries. Sorry, apologies. I had slide, but unfortunately there was an issue with them. Yes, thanks for the question. I think, yes, basically a lot of our work has been focusing basically on developing attacks against, privacy preserving anonymization techniques, mostly focusing on the risk of re-identification in individual level data, including recent work, for example, showing how 15 attributes, for example, would be sufficient to uniquely identify any US person 99.98% of the time. And I think, very much, these results being a case of why we need to move towards privacy engineering solutions, privacy enhancing techniques. And really how, like starting to release aggregates is the way forward. Whether it's going to put us out of a job, I wish in a sense, but I think we know from the theory that basically there is no free lunch when it comes to releasing data, and especially releasing sensitive data. So recent work actually we did has focused on attacking more dynamic systems and really showing that even privacy engineering systems can sometimes be attacked either because of bugs in the implementation or more fundamental flaws in their design. More recently, I think we attacked one system, so query-based systems developed by Aircloak. Basically, where we showed that despite the multiple level of static and dynamic noise that has been applied, actually with a new attack exploiting the noise, we could actually infer with fairly high likelihood and few queries the sensitive information that was supposed to be protected by the system, nearly as well as if we had access to the pseudonymized data set. So I think basically what I take from a lot of this is really that, clearly anonymization in the old de-identification release and forget model, does not really work anymore. It's clearly time for privacy engineering to really find a way to use data while preserving privacy with some caution that none of them are a silver bullet, and there's really a need to constantly research new attacks, new limitations, or assumptions that we would build into these systems to really ensure that they reach the intent of the law.
Thank you so much, and I definitely want to get back to your discussion of where attacks can still come in, even with these technologies. First, let's turn to Andrés, who works at the Spanish Data Protection Agency. You, of course, your office is in charge of, among other things, implementing the GDPR and making sure that companies are complying with its provisions. You have been very productive over the last few years, your office, in putting out a lot of guidance documents and materials. For example, in 2019, you actually published guidelines for privacy by design. Can you talk about the process you went through to produce those materials and what challenges you might have faced?
Well, first of all, I want to thank you for being part making possible this conference, even in this situation. Well, to begin with, I must say that this is by now it is a longer story because we started in 2015 working in what is now the technological and innovation division of the Spanish Data Protection Authority. We have produced a lot of materials. Uh, uh, Probably one of our main challenges when we began working in this direction was that we had a sanctioning perspective from the outside of the authority. It was quite difficult for us at that moment to contact the researchers, innovation sectors, because they were afraid of us. That's the truth. But now the situation is been changing. It's been, but a heavy work has been done in order to change this view of the Spanish data protection authority, data protection authority. Well, there is also another challenge that we must face because technology may be neutral, but sometimes organization researchers are not so neutral as technology should be. So there is also we always must find some balance between the interests of organization and general interest that the data protection authority is looking always for. In the end, as far as the tools that we have produced for researchers, because we also have a tool for researchers and for developers, and tool for data controllers and data processors. I'm beginning to think that sometimes that data controllers and data processors understand that the use of a given tool in order to help them to face GDPR is just GDPR. They understand only a formal approach to the GDPR, and there is not that culture of proactivity that involves, among other things, this data protection by design and data protection by default. I will provide you all my comments from the point of view of Data Protection Authority and from the point of view of GDPR.
Thank you very, very much. I want to kind of dig into the details. What are we talking about here? And Francois, maybe this is a question to start with you. Can you discuss some of the specific types of privacy enhancing tools and technologies that you're seeing or that you've worked on, and whether or not we are seeing actually getting to the adoption of those tools? You talked about taking things not only from concept, but actually into implementation. Are we seeing those get used more broadly?
Yes, definitely. So part of the work that my team at Google has been doing for the last few years has to do with federated learning. And the premise of federated learning is that user data stays on their device. And instead of, if you wish, shipping the data to a server, a global server where machine learning would happen, we ship the computations of machine learning to the devices. So machine learning happens, a model is trained on users' devices, and models from different users are aggregated together at the server level to produce a general model that can be downloaded on more devices. And the specific area where we started working on this technology is the mobile keyboard. So imagine that you have an Android phone with a mobile keyboard, and you want to have better next word predictions on the suggestion strip of your phone. So to provide those suggestions or predictions, you need to have what we call language model, which is essentially a neural network nowadays that gives probabilities to sequences of words. And what I mean by that is that if the language model types "the cat jumps on the table," that should have a high probability. It's a common sentence in English. If instead you type the table jumps on the cat, that's not a very high likelihood sentences in English, and it should have a low probability. And so deriving probabilities of this sort from user data on their device allows us to figure out which word we should predict based on what you've typed so far. So the mobile keyboard is very is a high usage application, right? So there's a lot of traffic from which federated learning can learn. It's also, for various reasons, a reasonably simple application where to develop such a technology, and that's why we started there. Even though I say it's simple, between the time that we started developing the technology, and I'm not even talking about the research that led to it, but the technology itself, it took us several years before we could put something in production that it was high quality enough, performant enough, secure enough, like all the characteristics we wanted. Once we could do that, then we could train more models with the same type of technology. And we could do that faster because now we had learned how to do it, essentially. And we could go to different domains. And so this technology that started with one single model that we were trying to train in a privacy-preserving way that took us so much effort, then became more of a technology that can be scaled, that can be ported to different problems. And so what we're doing now with it is porting it to different domains that are not necessarily related to the mobile keyboard, and where maybe the models are harder or the signals that we have to learn from are weaker, and where, generally speaking, the problem is complicated. So it's essentially a process of scaling more and more, and this is happening as we speak.
No, I kept the screen full screen with the PDF.
Very interesting. I'm interested. Sometimes we hear about this tension between privacy-enhancing tools
No, I
and
shared the
actual
screen. I didn't know how to
accountability
send
and
you a message. I
auditability
said in the chat, can I
of
speak?
both the information and the uses of those tools. Am I coming through okay? Can you all hear me?
Let me. Yeah, can you see my screen?
Apologies for that. So there's sometimes described this tension between privacy enhancing tools and trying to limit the amount of data being collected and being sent back, and actual accountability and auditability mechanisms that can show, for example, there isn't bias or any problems with the processing. Could any of you talk to, Andre, maybe you and your work, how these two items have come up, and if you found any of that tension actually play out in real life, or if that is a false dichotomy that's been set up? So maybe we can come back to that. One of the things to discuss is where these tools are coming from, and the fact that a lot of times they take so many resources to develop and use. You can't, small companies maybe can't develop that same federated learning model, Françoise, that you talked about. They don't have the depth of data available to them to really train these models on them. Is this a game, or is this game of privacy enhancing technology something that only the big players can participate in? Or are we seeing smaller companies also get involved in the development of these tools or in their use?
Well, I think that in the end, from the point of view of GDPR, you can develop technology like federated learning, and this technology should be spread to small bodies, for small companies. Because probably the way to transport this knowledge is by means of data protection authorities or by means of institutional like universities. But from the point of view of GDPR, there are mechanisms in order to consolidate this knowledge. For instance, mechanisms like certification and mechanisms like conduct. So we are in an initial state, I think, as far as data protection by design by default is concerned, that these technologies are concerned. And I think that there is still time to come in order to make these technologies more popular or more democratic, to say in one way or another.
Anybody else want to weigh in?
Yeah, maybe, and I think Françoise is definitely more qualified to talk about the scale required for some of these technologies. But I think it is something that, I mean, really, I would tend to see them as something similar to end-to-end encryption, right? They are the type of technologies that are quite amazing at doing something very specific. And in some cases, if what you want to do is this very specific thing, you can very much use these technologies, and these technologies can be extremely powerful to do this, including for small companies and startups. In other cases, when you have much more complex use cases that have not been well developed in research, then in some of these, yes, indeed, you might need significant research resources internally to be able to leverage and deploy these technologies. And in some cases, you might also need a fairly large user base.
Yeah, if I may, I would definitely second what Yves-Alexandre said. These are technologies that apply to certain domains, right? And that makes sense for some applications. It's definitely not the one solution for everything. And the development of such technologies does take resources, which is the reason why we typically try to open source these tools, right? In the case of federated learning, we have the library TensorFlow Federated that we have open source and that allow others to experiment with the technology. When it is a small model that we try to learn, we don't need a lot of users. If it is a larger model, then it takes, again, more data and therefore more users to train that model. However, there are also different uses of federated learning, not based on data that's on the device, but more at the business level. And we've seen that in the domain of healthcare, where different institutions can do federated learning together. And so this is a way where different companies of different sizes can come together to achieve something without having to share their data with the other companies that enter in that process.
So Yves-Alexandre, you talked about the weaknesses that are still present in these technologies and the fact that they can still be taken advantage of. And one of the things when I was looking at different privacy enhancing technologies on the market, I looked up the private connect tool, private join connect tool from Google. And in the FAQ, it actually says, we assume that these are good actors that are using these and they're not going to try to manipulate the tool in any way. How can not good actors still take advantage of privacy enhancing technologies? And what are the weaknesses that might still be out there that people should be aware of, the limitations of these tools?
Yeah, I mean, it's always, it's a very broad term first. I think, it covers, to be honest, anything from a query-based system that will make sure that only aggregate data or summary statistics are sent back to you, to federated learning, to homomorphic encryption, to private set intersection, in a range of other technologies. So it's very difficult to say, okay, like this is the vulnerability for this technology. I think in general, it's useful to think of these technologies as, again, they are extremely powerful within a specific setup, but like every technology, they do rely on assumptions that might or might not be correct in practice, and they also, need to be embedded within a system. And I think those are the two things that, when you start deploying them in practice, sometimes you have to, for example, make compromises on the assumptions, which might or might not introduce practical vulnerabilities. And similarly, even if your technology is very very good and correct theoretically, these are fairly complex systems, and so a bug or any kind of vulnerability can also come from small mistakes, incorrect assumptions being made while building the system, ranging from obvious one to much more detailed one in your randomization function that you're using. So it's really, I think, what the technology can do now. What are the assumptions that underline these technology? What are the assumptions that sometimes you might have to violate when you try to deploy these in practice? And then really the system perspective, the extent to which when you start embedding them within a system, some vulnerabilities might come from the system itself. So it's really, again, I think the most important thing to me is just to realize that these technologies are not black magic. They're extremely powerful within very specific, very useful most of the time setup, but they're not black magic, and sometimes vulnerabilities might happen. So this is something to be very careful with when deploying.
Well, I would like to add also that the only question is not to have libraries for enhancing privacy technology, but also from the point of view of GDPR, you also have, as data controller or as a developer, you have to integrate that technology within the context of regulation. That is, GDPR is a risk-oriented model, so you must manage as controls from this management system of risks. Only not only for the data subject, but also for the, have to face this map of controls also in order to avoid societal impacts. If you do not integrate this technology within the rest of the tools that is that data protection demands on your activities, probably you are facing only one part of your obligations. You need to integrate it within the risk-oriented model. For instance, you must play with tools like code of conduct certification, and also you have to integrate it with your security measures. You must understand privacy as a whole, and not only a collection of measures coming from privacy by design and privacy by default. This is only a part, but you have to integrate the whole, it in the whole.
I really like that idea of the fact that this is just one piece of kind of almost a pie, and you have to look at the whole pie before you determine the role.
But not the only tool.
Could you talk a little bit, Andre, about how you go about, or the ways the agency promotes the use of this one piece? How do you try to get or encourage companies to develop these tools and think about them?
I must say that I'm the person who analyzes and reads a preliminary impact assessment in this authority. And I must confess that I'm a little bit depressed with this resource, this value, I must say it, it's important resource. But the question is that I think any privacy by design measure in this preliminary IPAS assessment. I've never seen one, just one. I'm looking forward to seeing only one, but it's impossible. It's impossible. I think that there is a problem that we should face as data protection authority. You must understand that data protection officers are the ones who work with data controllers in order to provide him with pets, for instance. But probably data protection officers are more often than not are lawyers. This is difficult to approach. It is difficult to approach a lawyer to a technical measure. It's difficult. And it's even more difficult to approach this measure from a lawyer to a data controller. It's quite difficult. I think that we are in an initial state and there is a lot of work to be done, especially with data protection by design and by default. Probably privacy engineering is going to come to solve this problem, but in Spain, privacy engineering is something that is for the moment being quite far. I don't know any university in Spain which understand privacy engineering as a topic for their studies. Probably there is a lot of work to be done. Our last organic law dealing with data protection as a fundamental right has promoted this security and data protection as a right of the citizens, as a right to be taught in the schools and in the university. But there is still a long way to do. So the question is not to have libraries. The question is how to make privacy professionals use to these libraries, how to understand they are useful. This is quite difficult. I think that there's a lot of work to be done now.
I have to say, as one of those lawyers, I often find that this is way over my head. And in fact, a few years ago, I sat in on a tutorial on homomorphic encryption that was meant to be geared toward lawyers. And I walked out, my head was just spinning in circles about what I had just heard. And this becomes very relevant because you want people, you hear tech companies frequently talk about needing people to trust them. And if you don't know what tools they're implementing or how they're used or what they really do underneath the surface, it's hard, I think, to form that trust that people want regulators, that these companies want regulators to feel, they want their users to feel toward them. But they're so wonky and they're so technical and hard to describe. I want to talk about that in specific. What is the best way to communicate on what these tools are to the different populations and to really get across a level of understanding that's significant and penetrates that surface level of just good or bad, to get past some of this misunderstanding, I think, that's permeated the sector.
I'm happy to go. Basically, I think from my perspective, it's actually, I think very often these technologies are actually taught the wrong way. Meaning that very often, again, as technologists, we're excited about the math behind a lot of these under a set of specific assumptions that are basically pretty much accepted in the field, like the notion of an honest but curious attacker. And I think actually we should really pivot and really, when explaining those technologies, really try to bring it to the real world by, on the one hand, really emphasizing the assumptions that underlie these technologies and really try to put these forward and see if these are, from a GDPR perspective, are those assumptions one that we as a society and that data protection authorities are okay with, on the one hand, and then on the other, I think this is very much the value of some of the attacks, which really are trying to, in practice, in real world scenarios, poking at these technologies and then basically see, given everything we know today, how well can we attack these? What can we extract from these? And are these, too much to be considering these technologies anonymous data, for example, or anonymous technologies allowing you to use data anonymously? Or actually, is it possible, but it's such a high bar that at the moment we're okay with it? So really, to me, it's on the one hand the assumptions, and really very clearly explaining the assumptions, and on the other, I think potentially a bit more focus on attacks in real-world settings, and then trying to see the extent to which this is something that we are concerned about today, or something that at least today we're not concerned about. So really, this more security mindset.
You bring up, I mean, you even use the word anonymity, which I feel like somebody who isn't in the tech space. We started off with your remarks on the fact that de-identified data can be re-identified, and people may not get that the ability that does not mean this normal word that they feel like they understand doesn't mean from a technical sense what they feel like it means from a real world sense. And I think we saw that a little bit actually with the development of, we're all here remotely, we're staring at boxes, we're not in Brussels. Why? Because there's a global pandemic raging outside. And one of the ways we've tried to combat that is through these contact tracing COVID exposure applications. And Google and Apple did a really good job, I think, of putting together a tool that enhanced privacy while allowing people to determine whether or not they might have been exposed. And still we saw rejection of that by people who didn't understand that it was privacy protective. I personally encountered several different posts from people saying that they would never turn this on and outright rejecting its usability. How do we break that barrier and try to get people to know, even if they might not see usability for some ways, that there are actual tools that can benefit their lives and make sure that their data is protected?
Well, I must confess that I'm rather pessimist because the user is configured like what I call trust by design. So user don't worry for their intimacy, for privacy. If they worry, is because they have had a problem. They usually believe that if an application is going to access this camera, it's just to take a snapshot, for instance. But they never think that this access might be undiscriminated. So it's a question of education mainly. So that's why we introduce in our organic law this right of education of privacy. And from the perspective of the producers of services of goods or of the economic the digital economy, I think that they must understand this is not a question of a formal of facing just GDPR. It's not only a question of facing GDPR to avoid sanctions from Data Protection Authority. It's a question of trust. It's a question of improve, like Françoise said a little before. It's a question to improve services, products, applications, not only to improve privacy, but the benefit is that you improve privacy, you improve your privacy, the privacy of your users, you improve the competitiveness of your products. You are more competitive. There are a lot of advantages. Trust of your client, trust of your users should be at least, I think, a key part of your business. Just to mention that here in Spain, when GDPR came into force, there were big companies that didn't consider important GDPR. But the key that data protection officers based there to argue and to convince them was trust. If we if we miss the trust of our clients, if we miss the trust of our users, we will miss our business. Business is linked to trust intimately.
Yeah, I mean, I think I think it's great that you bring up COVID tracing or contact tracing apps. I think they're quite a unique piece of, I think, both privacy engineering, the challenges to communicate why are these okay while were others not okay. And also potentially the role of experts, ranging from academics to data protection authorities, in really trying to be a neutral, independent voice, being able to communicate the possible remaining risk with this application, and at the same time the fact that even if some risk remain, overall, they strike a really good balance, and people should really use them. So I think it's an excellent use case, an example of what privacy engineering technology can do. Something that was, invented at ETH, passed on to Google. I think really helped us to go from a lot of fears, I think, in the privacy community at the beginning, that these apps that the government is going to force you to install on your phone, that they're going to be recording Bluetooth and your location, send everything to a centralized server. I mean, this is the privacy nightmare for so many people in the community, and we ended up, quite fast, developing and deploying ultimately a technology that strikes a pretty good balance between usability and bringing utility in the fight against COVID, and protecting privacy.
So I have a question from our audience, from Sasha, saying some companies use privacy preserving technologies with inadequate parameters for protecting users' privacy. What can we do for preventing such quantitative misuse of technologies?
I'm happy to go unless Françoise wants to jump in.
Please go ahead.
I mean, it's gonna, again, to me, it comes back to what are the assumptions, the likelihood, and the practical risk that we can show. I think the question might refer to the use of epsilon, for example, for some privacy engineering techniques like local differential privacy, and then discussions on what is a reasonable epsilon. And I think, to me, really, this choice of epsilon from a societal perspective should probably be linked or studied with respect to the likelihood of attacks, right? It's pretty much the same way than, back in the days with the identification, we were considering, who the attacker might be, what is the likelihood, what kind of information might this attacker have access to try to re-identify someone. In the world of privacy engineering, we need to, basically build the same kind of attacks and attackers, and then try to see what we think, given the epsilon that is being used and what an attacker might have access to, what is a real world risk versus something that, at the moment at least, is mostly in the realm of a theoretical vulnerability.
Could you explain just shortly what epsilon is, real quick, just to people who might not know that world of differential privacy?
Basically, take it as it's a measure of the privacy preserving capabilities of your system under a certain number of assumptions. So it's basically within a set of assumptions. This is privacy preserving your system is. And then there are, depending on the kind of technology you look at, the kind of protections that are being put in place, and a range of other things, more or less accepted values for epsilon. So it's really, it's within a specific setup or privacy preserving your system is, but you can't necessarily, take the epsilon from one system and apply it to another. And it's not because one is an epsilon of one that it's much better, for example, than an epsilon of 4.
If I may add to this, when I started when my team started working on differential privacy, obviously I read all the literature and familiarized myself with it. And the value of epsilon was something that was kind of mysterious to me, right? What makes a good epsilon, what doesn't? There is the theoretical aspect of it, but how do you think of it in practice? What was really the question. And so when we trained our first neural network with differential privacy, I started wondering about what it meant in practice. So we did exactly what Yves-Alexandre was saying, of conducting attacks against our own system to see, in that specific case, how much data it unintentionally memorized. And doing this exercise was very illuminating to us to understand, as a whole, without relying on the math, without relying on the conviction that our code was correct, we could kind of see it from the outside and see how well it performed under those attacks. But interestingly, doing so, we also started observing new properties of how specific algorithms like federated averaging interacted with differential privacy, and how different that is from central learning. And so there's a whole body of additional research that emerged from those investigations. And I think we learned a lot from it, and there's a lot more to learn there.
I feel like the subtitle for the world of privacy and data protection could be "There is a lot more to learn," yes. Just across everything.
And it's really, I just, if I may, I just want to jump in. I absolutely, again, I just absolutely agree. I think to me, it's really, we moved from, basically a world of heuristics. Given a data set, this is kind of what we can do, and the assumptions were quite, blunt in the sense of this is what we assume to be the quasi-identifiers, what an attacker might have access to. And I think really now we move to a world of much more formal guarantees in theory, much more solid theory on the one hand, and then really practical attacks, and really these two being the fundamental component to try to build real-world system. Is on the one hand we have the theories, which is extremely useful for us to understand where the leaks might be coming from and what we're doing and what are the properties of the object that we are working with. And on the other hand, the attack, so that we can actually see exactly, coming back to the epsilon, where do we set it? What is something that is reasonable for that specific application? And I really do think that it is the combination of the two that will allow us to build good, useful, practical systems.
So I have two questions I want to ask together because I feel like they're the flip side of each other. One is from Kevin, asking if the efficacy of these technologies would be weakened if they're disclosed or well known by the public. And the other from Nicholas, asking about what about open source? And Françoise, you talked about this a little, as both a solution, he says, a legal obligation to force the submission of technology with the objection of privacy. Can you talk about the flip side of public knowing and understanding the tools versus the question of open source, and even a legally obligated open source?
Françoise, do you want to go? Do you prefer me to take it?
I thought Andrés would start with the legally, but if you want to go with Alexandre.
Oh, yeah. Basically, just very quickly, I'll tackle the security by obscurity or privacy by obscurity one, which is the easy one. They shouldn't really. I think there is quite a broad consensus in both the privacy and the security community that the security, the privacy, the strength of your protection should absolutely not depend on secrecy. You should not rely on thinking that you invented this amazing new method that no one thought about. This doesn't work. It has been shown many times in practice, and that's actually one of the first things that I start in my privacy engineering class. Is I give students pseudonymization method. And then basically we together show how we can easily break pretty much any pseudonymization method that is not a formal one that they come up with. So very much I think it's broadly accepted that your method should be not relying on obscurity. It should be it's exactly like encryption, right? I should be able to describe to you exactly what I'm doing, and yet you should not be able to attack the system.
And I think it's also critical to what Andrés was talking about before, the concept of trust, right? How do we want users to trust the technology that they don't understand? Now, of course, I'm not implying that we need to teach engineering and deep mathematical techniques to everyone who uses technology, but some kind of education is needed and some kind of understanding from the users is needed so that they can trust the tools that they're using.
Well, when talking about open sources, I must say that privacy by design, privacy by default, as I said before, is not the only subject in order to promote privacy. Transparency is another subject to take into account. Information is another subject. So open sources might be a way of transparency. So because you have the source code and you can understand what's going on inside. This might be probably an advantage to take into account as far as GDPR is concerned.
So, Yves, there's a question specifically for you. It's quite long, but I'll go into it. What do you think about the security level of blockchains? This is getting a little outside of what we talked about so far, but do you think hybrid blockchains could be a means of preserving privacy, provided a sufficient level of encryption is ensured? And is it possible to level up the encryption in these systems?
This is beyond my area of expertise. To be honest, I think some of my colleagues at Imperial, Ben Lifshitz and Will Nuttenbell, have been looking at the privacy and security of blockchain, but this is technically outside of my expertise.
Well,
from the legal perspective, for instance, well, I must say that blockchain technologies were created for one purpose. This is not a general purpose technology. We cannot reduce data protection to security. We cannot reduce data protection to encryption or to hashing algorithms. As I said before, we have to consider data protection as a whole. And GDPR provides tools as a whole. Blockchain was a technology developed for a given purpose, but it's quite difficult to understand to what extent that technology can be used in order to deal with personal data, especially to be used in order to preserve data subject rights. We must understand that probably blockchain was what it was at the moment when it was created, but probably blockchains need some more additional developments, actions to be developed in order to preserve data subjects' rights. For instance, there should be mechanisms in order to reduce the extent of the whole chain. There is it's not only a question of technology, but technology is to be implemented with warranties for the rights of the persons, not only a question of technology. Not only think about functionalities, but also think about the problems that you can cause to society and the problems that you can cause in the long term to data subjects.
So I want to tie some threads together across the conversation. We spoke about the importance of trust, and we spoke about the fact that privacy-enhancing technologies are not foolproof, and they're not guaranteed to not be misused. What happens when they fail? If you use a privacy-enhancing technology to further enhance trust and to get people to maybe participate in or use a tool as a selling point that they wouldn't normally, is there a potential that the consequences of failure could be even greater? And how do we try to mitigate those if people are maybe submitting or interacting with them in a way that turns over more data in a way that they think is privacy protective, but something has gone wrong? For reference, this is something we talk about in security a little bit, security policy. When people think something is encrypted and secure, they might send more information across that channel. And if that channel ends up not being secure, the compromise of data that they wouldn't necessarily have shared otherwise could be significantly more catastrophic because they thought it was going to be secure. So in the privacy space, if they think that they have a level of privacy or that they're going to be provided a level of privacy that doesn't ultimately end up being the case, do we have mechanisms to respond to that?
Well, data protection provides you with mechanisms because data protection is intended to secure your data not only from the point of view of security. We must be ready to understand that security is going to fail sooner or later. So data protection provides you with things like minimization principle. So data protection by default provides you with tools to implement this minimization principle. So when things go wrong, you always have the likelihood to reduce the impact on data subjects and the impacts and the societal the impact on society in general.
Thanks. I think it's an excellent question, because indeed, I think, because we're moving to technologies, we're moving to software, possibly open source, possibly standardized. It really changes the dynamic and the potential consequences of an attack. I think in the old world of the identification, you were releasing a very specific data set. You had a fairly good understanding what was in the data set, and how you've protected it. And if it turns out that you made a mistake, you know that this specific data set is at risk. When it comes to privacy engineering, if the same technology has been deployed in a broad range of contexts, the risk of a new vulnerability being discovered basically impacts a lot of data set across potentially a broad range of companies. And so I think we are moving from privacy to security, and really, the need to make sure that we start having models to make sure that these are going to be patched fast enough that we try actively to find these vulnerabilities. So it's really I think the bar is like, an order of magnitude higher than it used to be in the past, but the impact of that a vulnerability would have is potentially much broader.
Are there ways that we could mitigate some of these shortcomings or potentials for failure? And in particular, we have a question on if there are solutions to mitigate the shortcomings of anonymization. But I think even more broadly, how are we thinking about mitigation of potential negative consequences?
Well, I think that anonymization is not only a question of technical, it's not only a technical issue. You also have to work with another kind of measures. For instance, in Spain, we have a law of transparency, which provides the information of public administration to citizens who are interested in that information. And sometimes we have some levels of compromises or agreements. You can download public information from many servers on internet in Spain, but you're not allowed to do whatever you want. So there are contractual clauses and things that there are compromises to protect that information, like the compromises for not to attend the identification of a person, and the compromise of communicate to the data controller that there is a person that has been identified even accidentally. So as we say in our anonymization guide, there are a set of warranties to be implemented to the anonymization data processing, but not only technical measures.
Yeah, go ahead, please.
Sorry, but just a short thing. Just on the technical side of things, it's also whenever you're dealing with an engineering problem that's complex, often the best protections is to have several methods that work together, right? If we rely only on one method and a vulnerability is found there, the whole thing falls apart. If we have several methods, we may be able to contain the problem a little bit more easily.
Yeah, I was gonna say the same thing. It's very much, I mean, to not become. I think the biggest risk is to become overconfident that your method is perfect, and indeed, it basically means that do your very best, and the method alone should be sufficient. But make sure that you do have safeguard mechanisms in place, both technical and legal ones, not only relying on one layer of protection, because even if that layer is very strong, if there is one vulnerability, you're left with nothing. So it's very much having several layers, both technical and legal, on top of the technology you're deploying.
So we started talking about, when I did my introduction, about these two drivers of privacy, about the technology and the law and regulation. And in particular, Andre, you talked about needing a holistic approach, data protection as a whole, and making sure that you're looking at the whole pie and not just that one piece. Going kind of full circle, even with GDPR, and as I said, coming from the US, we're just trying to catch up. What could we do with regulation? And what would you think, looking ahead, should be done, or could be augmented onto GDPR or added into whatever the US ends up coming up with, or other countries or regions, to better support work in this area, and to assure that what's done going forward is as protective as possible? We had the question about mandating open source. and if that should be a legal requirement. Is that a solution, or are there other things that we can do with the regulation to protect the technology?
But I think that technology will also have the likelihood to fail. Security will also have the likelihood to fail. So that's why GDPR and data protection in general provide you with some tools in order to mitigate the harmful consequences of technology. And we must build your product or services thinking in that possibility.
Yeah, I think one thing that to me is really, as a technologist, I was quite impressed the first time I went through GDPR. It's actually the quite technology neutral and friendly approach they took. For example, if you look at the definition of anonymization, GDPR took a very different route, for example, than what existed in the US with HIPAA, in the sense of they did not try to define a technical standard, or even certainly not a technical method, but not even a standard for what would be sufficient to consider data to be anonymous. On it it focused on basically saying, okay, listen, data is anonymous if you cannot re-identify someone, and these are three quite easy to understand criteria that one should consider when evaluating whether this is sufficiently anonymous or not, and even going further and saying, okay, this will have to be reevaluated as technology evolve. It's basically, you need to take into account the best known attack today to consider whether the method or the process you're using is safe enough. And I think that is one thing that, honestly, as a technologist, is quite impressive in GDPR, in a way to define basically goals with respect to the technical state of the art, and really try to stay away from this temptation, in a sense, to be, okay, these are the kind of techniques you should be using, or these are the kind of thing that you should not be doing, and try to be more practical, because technology evolves very fast. And especially when it comes to anonymization, it's much better to have something that will advance basically naturally with the state of the art and high level criteria, instead of, HIPAA, that was basically, these are the 16 attributes that if they're not in your data set, your data set is anonymous. And obviously no one relies on this these 16 criteria anymore, but it's just to give you a sense of how I think quite impressive work has been done with GDPR in defining, for example, anonymous data. One thing I think you're asking is, like, what would we change? And I think this one, to me, is, I would probably have gone a bit further towards what you were mentioning at the beginning, which is this notion of transparency. I do think that we would all benefit from a little bit more transparency in what are the mechanisms that are currently used, for example, to anonymize data. A bit more description on, this is what we have been doing. This is how we have been anonymizing your data. Not every single detail. This is not a scientific paper, but high level, 2-page description of how you've been anonymizing data.
All right. Well, thank you, everyone. We're at time. It's been really great to hear from you all. And I'm sure this is a conversation just beginning. As technology continues to evolve, we're going to see, I think, more and more of these tools, and have to ask more about how to regulate them, how to approach them, and how to communicate them to the rest of the world. So thanks for beginning a conversation, not an end. And I hope you have a really wonderful evening. And I hope you all are enjoying the end of CPDP. Thank you.
Thank you.